people attending. Very nice to make some time free to come to our webinar or attend our webinar, because I'm sure there are many webinars going around now. So yeah, today we did 2 days ago fiber cleaning inspection. So today we will talk about a little bit about testing PoE. You still see my screen, right?
Yes, we do.
Huh?
Yes, we see your screen.
Ah, because I don't see the green bar anymore. So yeah, we will talk about PoE testing. I will give a little bit backgrounder on technology and what are the drivers for PoE. But of course, we as Fluke Networks, we focus on the testing part and how you can prepare for a proper power over Ethernet installation and what all comes looking with it. So so first, a few backgrounds. I think most of you know now already, Internet of Things, it's booming, a lot of data out there, sensors out there that are being connected to the network. I took a slide from somewhere just to show you how much PoE equipment is out there, which is all related to Internet of Things. 12% cumulative compound average growth rate. What is driving it? It's mainly, I think, because you don't have to run 2 cables anymore, not a power cable and a data cable. A lot of people want to run everything over 1 cable. It's related to smart buildings, smart cities, where more and more sensors are being implemented. The nice thing, good thing, or not good thing is it's mainly over copper. A lot of people always ask, hey, copper will disappear. Well, we as Fluke Networks, we say no, it will not disappear, because all this PoE and Internet of Things, it still needs copper because of the power you want to supply over the copper, which is not always done or possible over fiber, for sure not, and wireless. There are some technologies they are trying to implement, but still far away. Another slide again to show you how it is growing. More and more devices out there that needs to be connected. Internet of Things, PoE related. Whoever you ask, Forrester, Gartner, Kearney, General Electric, they all are indicating there is a huge explosion on Internet of Things devices. Here you see a picture where in the past you had your phone lines, the phones were connected to your phone network, let's say. There was the IT network to connect your cabling for your computer for data communication, and you had your not only electricity but also some cables for heating and ventilation. So there were mainly 3 systems in place. While now in a modern building there are so many different cables or combined in 1 cable already. So you have different systems. You have a network, you have your heating still, what you had in the past, but you also have communication to the lifts, the actioning of the lifts, fire alarm systems. Your phone is now mostly voice over IP phone. Lightning is connected to the network. Cameras, especially security cameras, which I think it's different projects and different system integrators implementing the CCTV cameras and maybe other sensors, access control, call it. A lot of devices now being connected on the network. And all this information, as we mentioned already, your ventilation, lighting, all this information goes now over that 1 cable. And the challenge now is most of you, if you are an installer or consultant or end user, yeah, this cable is being tested mainly at the moment for data communication. Cat6, Cat6a, Cat8 in some extreme situations, but it's not really tested for transmitting the power over that cable. So we want to give you some insights and some information about, hey, what you should look for and what else you can test for not only the data communication, but also that power over Ethernet you need to deliver. Again, main reason we mentioned already, PoE. Why PoE? Because you can save a lot of money, cost, because you don't have to implement an electrical power installer, the 220 volt. You don't need to pull that cable or install that cable to power a device. You take the power from your data cable. So here you see a rough calculation. An average cost for a typical power to a device costs around $1,000. The outlet, the cable, the electricity, some transfers, maybe some other the manpower to implement it. While if you do it over your data communication network, over the structured cable, which you already need for your data communication, it drops to $250. So it's like a saving of $750, which you do on PoE. That's one of the main reasons why more and more PoE is being implemented. So yeah, we need more power. For those who know Star Trek, for the older people under you, like me, getting gray, but you remember maybe Scotty, we need more power, what Captain Kirk always asked for. So the same you see now a little bit in the market, in the field for these PoE devices. Maybe most of you know about the original or initial PoE devices. They needed 15 watt. We will come back. There are different standards who define them. This type 1 that they call PoE devices could be some sensors, some basic cameras, access control. You see here the cameras, for example, or some fire detection systems. So they did not need that much power. But throughout the time, other devices are being connected that need more power now. So you have 30 watt devices, type 2, according 802.380, Lightning, more sophisticated security cameras that have more information, higher resolution, ways to action to look around 360, or voice over IP phones that maybe need more power. And it went on. So a few years later, there were other devices, more powerful Lightning, more powerful cameras out there, even controls of access control, not only for the people, but garages here I see. And it goes on now. Now there are already 90 watt devices out there. Sometimes even you can power up a screen or even a laptop, but that needs higher and higher power, which will stress more and more your cable, and you need that to take that into account, that it's not just the data goes over the cable, but also this higher power. Just as an example again, which we took from a cable manufacturer, that they say, hey, depending on the categories and depending on the type of PoE device that you use, for example, you see here a type 1, which needs 15 watt. Remember, there's different wattages that you can have on PoE devices. It needs a certain current, certain number of milliamperes. And you see, the more wattage you need, the higher the current is required. Now, because of this higher current, that means that the cable will be heating up. So, and based on what category you install, take for example a Cat6 cable. For a type 2 and 3, you see here you need 600 milliampere, but that means that the temperature will be rising on that cable. So this you have to take that into account, that you don't measure that with your standard Cat6a or Cat6 testing. You don't measure the effect of that temperature rise on the cable that could happen. So you need to take that into account. So the recommendation is sometimes to implement even a Cat6a cable, even if the consultant or the requirements are Cat6, because of the heating will not be that high if you use that Cat6a cable. Just to give you some insights, hey, what is all playing now by adding or connecting PoE devices. So how to measure all this? So we would like to give you some insights on hey, what you should look for, what are the additional tests you can do. So we will talk a little bit more detailed about MPTL. Maybe you heard about it already, but what is it and how to test it? How the Ethernet Alliance will help you to identify which wattage you need for some devices. But then also later we will see how to really test it. Is it always true what is mentioned on the devices? And other additional tests is the resistance unbalance we will see, specifically for this PoE requirements that can help you to make sure your cabling is has the quality in place for your PoE devices on top of the data communication of the cable. So let's start with MPTL. By the way, if you have questions in the meantime, ask it on the Q&A. And I forgot the polling, so maybe while Ursula, can you start the polling before we go here? I think I asked about MPTL. Was that the first polling? See if you are using it already. So especially for those who do this CCTV security cameras, which need PoE, how do you test that today? Maybe you don't have CCTV camera installations, but then if you have them, how do you test it? Which setup do you use in your tester? Is it permanent link? Is it channel? Are you using already MPTL or you didn't know there is MPTL or? About 30, 40 people have answered, so just would like to have your way you do testing today. Wait a few more seconds till we have more answers. Okay, let's show. Can you show maybe the results so far? So we, yeah. So we can see here that the top. So the top still most of you use the standard permanent link test. Probably, yeah, because you will see you need maybe something additional to do the MPTL. Some still do even a channel test. It's good to have a discussion with those people. Why still why a channel test? Some of you do already, or second highest is the test with MPTL. So that's great. We can maybe have a coffee now, but let's talk about all the others. Why channel or why standard permanent link, or why you should not do it that way? So what is MPTL and how to test it? First of all, so yeah. So MPTL is a way to connect to an access, a camera or a wireless access point, and you connect it straight to the camera or the access point. So that is what nowadays is being done. Those who just answered, you're still doing a permanent link test. Probably you still have a wall outlet or a socket there where you take a patch cord and connect it to the device. But the disadvantages will be that someone can disconnect it here easily to remove the camera, let's say. So what happens nowadays, you go with the cable straight into the device. Yeah. But you can feel already how to connect this now to your tester if you do a permanent link test, how to connect that to your permanent link adapter, because you have a plug there, how to connect the plug from your permanent link to the plug of your connection to the camera or the access point. This is used for, again, wireless access points, cameras, locks, access control, sensors, most devices who have this PoE, power over Ethernet requirements. It's lower cost because you don't have to install anymore a wall outlet. So you can connect straight to your device. It's a cleaner look also because it goes straight. You don't have interconnections there, and it's more secure, as I just mentioned. For a camera, for example, yeah, it's not so easy to disconnect. You have to really cut the cable there but you cannot easily disconnect like a patch cord. Here you see some samples of what we call field terminated plugs, different brands, different ways of connecting it. But the thing is, yeah, this is still done in the field. So you connect at the end the plug in onto the cable, and of course then you have to test that also if it's according to the standards. So here's another way how this MPTL looks. So from your patch panel, you have what they call a consolidation point, and you go straight into your camera. So there is no wall outlet anymore. So there's a connector here, and here is a plug on your patch panel. So how to test this now? If you, let's say, some people answer permanent link. Yeah, okay, you can connect your permanent link here. We will see that. But how to connect it now here to your camera or to the cable that goes into the camera? You see different standards are working on it. The ANSI, TIA, BICSI, they are working on definition and how to test. This is a more simplified representation because we want to show how to test now this cabling. So you go from your patch panel straight into your camera access point, whatever, with an RG45 plug now. So how to test this now? Is this a permanent link? For those who said we are doing permanent link testing, well, yes, here it looks like, yeah, there you can do this permanent link connection with a permanent link adapter. But here, as you saw, this cable goes straight into your device, so you do not have this outlet anymore. So it's not there. And the final plug, it's not the plug of the plug that goes into your camera or your access point. So it's not a permanent link. Is it a channel? Well, again, okay, here you can have a patch cord that you use to do your testing. So that should be the patch cord that stays in place to your storage device or whatever. Yeah. But on the other side, again, okay, you have a patch cord, or could be the cord that goes into your camera to the wall outlet. So, okay, the patch cord is now included, but does it start? Does it start on the camera with the patch cord? No. Does it include the last plug? No, because the channel, as per definition, is not measuring, is excluding this from the measurement. While, especially on the camera side, you want to include the plug that goes into, or the connector that goes into the camera. So, and it's not included in the channel measurement. So it's not a channel. So you have to, what we call, select MPTL. It's defined in the different standards, TIA, BICSI, ISO, they are defining it. But you will have to use on one side a permanent link, and on the other side you will have to have what we call a patch cord adapter, which is different than a channel adapter. I didn't put here now a separate slide on a channel or on a patch cord test, but you can imagine if you want to test a patch cord, you will need, it will include the connector that goes, that's on the end of the patch cord. So as per definition, for a patch cord measurement, it will include that connector, which you want to include because that is where you made the changes on the installation. Remember a few slides back, you made these changes to put that field plug on the connector. But now you want to test that, including your connection. So you have to use this patch cord adapter. So that's the huge difference or the additional. This is still a permanent link adapter, but here it looks like a channel adapter, but it's not. It's a patch cord adapter, very specifically for doing this MPTL testing. So here you see it more clear. If you do the testing on one side on your patch panel, you can still use your permanent link adapter. The test will start from your patch panel, and it goes eventually a consolidation point goes up to the plug. You measure up to the plug that goes into your camera, and that plug that you have connected here will be included in the test because you are using a patch cord adapter. A channel adapter will not include that connector. So this is for testing MPTL. Patch cord adapter, one patch cord adapter, and one permanent link adapter. Plus, in your settings of your Versive, hopefully you all have already Versive or planning to buy one, because if you would buy another vendor, they do not have that. As far as we know, they don't have that MPTL setup, and or they don't have that specific patch cord adapter. So be attentive there. If you consider other brands, do they have this specific test? So here you select Cat5e channel, sorry, here, Cat6a MPTL, Cat6 MPTL, or Cat5 MPTL. You also have to put attention here that because you are measuring this plug here, you do need the corresponding socket into the patch cord adapter. That means there will be a different adapter for Cat5e, different than a Cat6, different than a Cat6a adapter, which is not the case with a channel adapter, because a channel adapter, it's not including the plug, so you can do it for the all categories. Yeah, so that's also good to know that you need different patch cord adapters based on the different standards. Yeah, that's Ethernet Alliance. On my host, I don't remember the second polling question about what it was. So if you can ping me again, or when you see the topic, then launch it. So Ethernet Alliance, a few words about this Ethernet Alliance. Just to show you, it's not a quiz you have to answer now. It's just if there would be a quiz and someone would ask you, hey, what is the power available on a power device for class 3? Would you immediately say like, oh, is it 30 watt? Is it 60, 90? Do you really know that by heart? It's 13 watt, by the way. Now, based on another question, based on 802.3 BT, what class of power is available from a PoE++ device? Be aware there is PoE, there is PoE+, there is PoE++, there is universal PoE, there are different kinds of PoE. And based on this standard, what class of power is available from a PoE++? So again, you don't have to answer us now, but if you think about it, do you know this answer very quickly? If someone would ask you, they have a device that needs PoE++, the answer is class 5 or 6. So it's not just one class, they are different classes. Yeah. Another question, how many pairs are used in a class 4 implementation? If you would be attentive, it was on one of the previous slides, on remember on the temperature, but nevertheless, a class 4 implementation, don't get confused with 4 pairs. So how many pairs are used in a class 4? Try to answer for yourself if you think you know it. So the answer would be it's 2 or 4. There is a class 4 implementation which use only 2 pairs. Just to show you a little, hey, it's not that easy, this PoE, because there are so many terminologies, different standards, different wattage levels, different types of the 4 types are there, the names that some people use, the PoE, PoE++, universal PoE, the negotiation, the Cisco, they have their own protocol to interrogate, the LLDP. And what about interoperability? Will a device which is PoE++ work with a power delivery device that is PoE+, for example? Will it all work together? Just to show you how complicated it is becoming, that's why this Ethernet Alliance is trying to simplify a little. Here they try to combine all these types, different classes, different wattages into one schematic or one way of giving it a terminology. And then you see here the power source equipment can have a certain class, and the powered device. So the power source equipment could be your switch or your router or whoever delivers the power, or your powered device. Always confused here, power delivery, it's not, it's the powered device. So that is then your camera, your sensor, your access point that needs the power. So the Ethernet Alliance is trying to simplify this, and then I think you can understand that if your device, let's say, is a 13 watt, a voice over IP, for example, the phone that needs 13 watt, yeah, that your power source equipment needs to have the same or higher wattage or higher same class or higher class to deliver that wattage, that power. Yeah? A device on 7 watt or a source equipment to deliver 7 watt can never be enough to deliver a voice over IP phone for that needs 13 watt. So these classes, it's mainly the numbers of the classes that are being used. So the Ethernet Alliance has made this let's say standardization, this numbering that, hey, if you have a power sourcing equipment, PSE, remember, of class 3, that can give power to power devices that have a class 3 or less. If you go back to the previous slide, so a class 3 power source equipment can deliver power to a power device of class 3, 2, or 1. I think now it's getting more simple that if you see this on a device, the PSE, the switch is showing number 3, then you know, my receiving device, my power device need to have 3 or less. You know? And that simplifies the whole nomenclature, or how do you call it, all the different terminologies for classes, types, PoE, etc. It really simplifies it. So now you can say, hey, in this case, this will work. But if you have a setup, for example, that your power source equipment is number 3, remember the class 3, and your power device needs 4, this will not work. Of course, this is now something that you say, okay, this is advertised on my equipment, but still there could be other reasons that it's maybe still not delivering that power that you do need for your device. And we'll come back to that, how you can measure that. Before we go there, another terminology, that's resistance testing for PoE. So that's the third one. What's the polling question about resistance unbalance? Sorry.
The third question was not posted.
Yeah. Okay, only one question. So 4-pair PoE in operation. So how does this, or how can we explain what this resistance unbalance is and why you have to measure it? So if you have a PSE equipment, power source equipment that needs power to the power device, then you have to transmit this over your data cable. And you can somehow imagine that this power needs to go over that cable. So very simplified, you have your, again, always your power source equipment, your switch port, whatever, that has a certain power can be delivered over that cable to your powered device. Imagine here your camera or your voice over IP phone or whatever. Yeah. So that will go over that cable. Now, if your cable is from high quality and what we call in balance, if the resistance is in balance, then this power will nicely be transmitted over that cable to your powered device. But you can imagine if there is something a little bit wrong on that cable, quality, bottom line, the resistance in that pair, in between the two wires, if the resistance is a little bit different, then this power will not be properly transmitted over that cable to your powered device, and it will not have enough power or will not properly working here. So that's we try to simplify here what you need or why you need to test this cable against what we call resistance unbalance. It needs to be in balance, so you test against the unbalance of the resistance. So here you see the requirements in the cabling requirements, standards, they define this already. If you would go into the TIA or the ISO or the ANSI standards, it would be there. They would have this not a requirement. They say, okay, if you want to test your cable, you need to do next LFX, length, wire map, etc. And there will be also a test called DC loop resistance and DC resistance unbalance. But a few years ago or many years ago, when they set up this standard, yeah, there was no one who could measure it. So that's why the TIA said, yeah, if no one can measure it, then we cannot oblige it to have it in your test report. So that's why they left it out in the requirements to have pass-fail on your Cat6, Cat6A or Cat5e testing. Yeah? So it was there, the parameter was there, but there was no requirement, no must to test it. Why? Because there was no tester who could do it. Today, Fluke Networks has a tester on the market who can test this loop resistance. So we recommend now, and we ask consultants, and maybe consultants will already ask to do this testing. Why? You saw that in the slide before. It will give you a higher quality, a better measurement, a better indication of the quality of the cable, especially for PoE implementations. So you see, it is optional in the TIA. It's not a must, because still they didn't switch it on yet, or they said, yeah, these requirements, it takes some time. So you need to lobby, you need to get agreement of all the members of the standards committee. So that takes some time. But we expect at some time they will ask now, hey, to do this testing, especially with all these PoE devices in the market, you have to do this test too. In the meantime, some consultants can already ask it. Nevertheless, our recommendation is test it already, because it will give you a higher level of quality of your cable. Here a little bit deeper in detail how it works or what is being tested. So there is a parameter called loop resistance. So it measures the resistance of your wires in the loop for each pair. So for all the pairs, it should be less than 25 ohm. So again, the parameter is in the standards. It is defined what is the limit, what is pass-fail limit, let's say, but it's not a requirement. It's not a must to do, but we ask you, hey, do it, because if it's failing, that means your cameras will at some stage maybe not work anymore. This is what they call the pair-to-pair resistance unbalance. So what they do is they measure, or what we do, or what the requirement is. So you measure the resistance from each pair and then compare it to the other pair. So you will have different combinations. There will be 6 combinations, 1, 2, 3, 4, 5, and 6. 6 pair combinations. This is the formula that will be calculated based on the measurements. And the values need to be less than 0.2 ohm or 7.5% of total. So the limits are there. You can test it, and it gives you a better quality. Another one is what they call the pair resistance unbalance. What they do here is they measure the difference between the resistance of each wire in each pair. It's a difference of the resistance in each wire for the pair, and again for the 4 pairs, 4 measurements, this should be less than 0.2 ohm. Yeah, so these were the 3 parameters that can be measured, and we recommend you should measure that, and we will show you how or where that is. What if it's failing? What could be the cause? Well, overheating could be the cause. Or what could result if this resistance unbalance or pair-to-pair balance is not passing. You could have overheating in your cable because of this resistance unbalance. The power through the cable will generate overheating. Yeah? You could have power loss. We showed that a few slides ago. And you could even have data loss because of these effects on this resistance unbalance. Why is this, or what could cause that? It's similar on a standard installation. It is bad workmanship, or the cable quality is not high enough to pass this resistance balance or resistance unbalance parameters. So if your workmanship is not done properly, you could fail these parameters. If they fail, you could have issues with your PoE devices. camera will not work properly, or it's maybe it will work, but maybe the resolution is not high enough, or you cannot see 360 degrees, or some things could happen on your camera. And what if, if something happens, burglary or something happens, and you do need the images and they are not there, then you have a huge problem, or the end user will come back to the installer and ask, hey, what did you do? Why is it not working? Here you see the screenshots of the tester that says, hey, the 3 tests, the loop resistance, the pair unbalanced for the 4 pairs, and you have the pair-to-pair unbalanced. There you have 6 measurement results. So they have to be within certain limit and can give you then pass-fail if you ask to test for these parameters. Yeah. So this was the resistance unbalance. To come back now to this, remember the Ethernet Alliance, the different wattages and the classes of power you have to deliver from your power sourcing equipment to your powered device. So what, even if then it's not working, you see the stickers on the devices, it's showing you, hey, I deliver, I have a PSE 3 and my power device is 2, and still it's not working. What could be the issue? So we would like to show you a little how can that be solved, or what is the typical way today that a technician is doing. Well, if it's not working, he's trying a new device, he replaces the cable, he tries a different switch, or he calls a network engineer and asks the network engineer, hey, which power levels are on this switch post, can you check it? But before he goes there, before he asks the network engineer, probably the network engineer will come back and say, yeah, but did you try another device? Did you check your cable? Did you check, etc. Before he will spend his time on trying to help. So it would be good if the technician could prove that the wattage is not as it is advertised on the device. So here, very simplified, let's say. So someone wants to connect a voice over IP phone to the network. Yeah? The voice over IP is trying to connect. The phone is trying to connect and says, hey, can I have 12 watts? Should be maybe 13 watts. Remember the class 2 or 3. Yeah? So can I have 12 watts? And the switch says, sorry, but all my other ports, they are already delivering power to other devices. So sorry, I do not have enough power for you. So he cannot connect the phone. So what is the technician now doing? So he has different steps he can do. So he can try another phone. He tried, unbox another new phone, cost some money. So now what he has to say now to the next user who sees, hey, did you use this phone already somewhere? Then there is, but yeah, he does that. He takes another phone and it's still not working. So then he thinks, oh, it's not a phone, so it must be my connector. Maybe I did something wrong. So he reconnects. Takes some time, 10, 15 minutes maybe to reconnect, and then check it again with that phone. Again, it's not working. So what else he can do? Yeah, maybe he says, yeah, maybe the switch port is not properly configured, or maybe the wall outlet is not connecting to the switch port. So he can change the switch port and go to another port, but also that is not giving a solution. So the only thing what is left is asking the network engineer, hey, can you please check what is the wattage I'm getting on that switch port? And then, yes, when he calls the network engineer, the network engineer says, yes, you're right. It's only, what, 7 watt or what that I deliver on that port. And I'm sorry, I cannot deliver more because all the other switch ports have been programmed and configured already. But if you, the engineer can say, hey, if you connect it to another switch port, to that port, then it should work. You can imagine this takes quite some time, taking another phone from the warehouse, reconnecting it, changing to another switch port. This could easily take up to 3 hours, including the walking around, going from the phone to the switch port, making the changes. Can take easily 1 to up to 3 hours. So you can imagine this takes, this costs money, takes time. It's almost half day work just to connect or trying to connect one phone. So could this not be done easier if that technician would have the right equipment, if he would have a better tool? So that's why we as Fluke Networks, we try to help that that technician in the field by having this what we call microscanner PoE, which has a display. It's one display which shows all the information he needs for that connection. You see here he can tone, but also mainly the PoE here, how much wattage there is, and which class of power that the power sourcing equipment or the power device needs to get, or that the power source equipment is delivering. So by just connecting this tray to the PSE equipment, he can give, you see an example of a screen. So it's 802.3 class 7 that he measures from that power sourcing equipment. It gives 62 watts. Yeah? And you can see if it's single or dual pair that is being used. So now the technician can use a simple tool to detect immediately, is it a cable, is it a connector, or is it the power from the switch which is not high enough for powering my camera or my access point or whatever he needs to connect to the network. So this will help him tremendously to get faster information to the network engineer, for example, to say, hey, everything is fine. Look, cable, wire map, everything is fine. I only get class 2 or whatever, and I only get, let's say, 7 watt while I need 15 watt. Please make the changes on your PSE on the switch. You see some other screenshots. Class 5, 40 watt. Class 7, 62 watt. Dual. If there is no PoE available, just voltage or passive cable, so you can, it will show you almost automatically what is available on that cable. So here you see the steps. He connects with his MS PoE. In a few seconds, he can show that it's not the cable, that it's not the phone, because the MS PoE display say it's a class 1, 4 watt, which comes from the switch port. He informs the network engineer, and after 5 minutes, the network engineer, for the total time to solve the issue, he shows through his command, yeah, it is, I reprogrammed it and now it should work. So this device gives you much more immediate information in a short time to technician to do the troubleshooting much faster. Any questions? You have posted the questions in the meantime, I assume.
Yes, Werner, we have a couple of questions. I will start with two at the moment. We have a question from one of the folks called, are all the Fluke networks able to do resistance tests? I think resistance or resistance unbalance. So can you explain which tester can do resistance and resistance unbalance?
Yeah, so in principle, the Versus, the DSX 5000, 8000 can do resistance unbalance testing. You can select that in the tester. Later, if some time left, or those who want to hang on, I can show it on the tester, but you saw it also on the screen in the presentation. So it's the DSX 5000 and 8000 who can do that test. There are some other devices, maybe but they do not show that resistance unbalance. If you heard about DSX 600 or 602, that cannot do that test. MS PoE is not showing resistance unbalance. Other devices are not showing that. So it's only mainly the DSX 5000 and 8000 who will do resistance unbalance, because it's part of the certification. Yeah? You need first of all, you need a certification tool. Microscanner, IntelliTone, whatever, Cable IQ is not a certification tool. It's part of the certification process. If you want to add something, Wael or Salah?
From my side, this is all good. So the other question we have, before we go for the second question, ladies and gents, we have a Q&A button at the deck in front of you. So if you have a question, please feel free to click on that one and ask your questions in that area so that we can have the visibility in front of us and we can share straight with the presenter, Werner. The second question, Werner, I think you went through it. It was very at the right moment when that question came. Since the cable carry power and it is of high voltage, can it damage the equipment if we have a wrong termination? I think I'll leave it to you
can answer also. I mean, one input I have, because we didn't go through everything, so there was already the overheating, but also, for example, if you have a high voltage, if you now have power over your cable and you have your data connection, so now you have the issue even that if you connect and disconnect your cable, you could have now sparks on your cable, so you have a higher voltage. In high voltage, normally PoE is 12 or 24 volt normally, that's not high voltage. So you're not going to transmit 220 volt over your data cable. That's not the purpose. But even with 24 volt, you can have now sparks on the connector every time you connect and this or disconnect, connect. So that could also affect your cable system. I don't know if you want to add something else.
Yeah, I think I would add one thing on top of that. If you have a cabling system which is already installed and you are expecting the quality of the cable is perfectly good, and you're expecting to run a 90 watts type 8 PoE, but if the termination of the jacks is not good, I think what we can tell that the PoE at that level might not work because the equipment cannot synchronize to that level. So you mentioned that in one of the slides earlier, PoE can stop working if we have an issue with any of the components. So that's where I would add to what you have mentioned as well, apart from the sparks.
Other questions?
Yeah, so we have a question. MPTL a specific adapter, or you can do with a normal channel and permanent link adapter? Answer that, but maybe you can repeat it.
Yeah, so let's go maybe.
But just sure.
Yeah, in short, short answer is no. You cannot do MPTL with your channel adapter and a permanent link adapter. That's why we maybe need to. So yes, the permanent link adapter, that's fine, but the channel adapter here, it's not fine. The main reason is, as per definition of the channel test, or as per definition in the standards, they say a channel test is not including the connector, the plug of what you use to insert into your camera or your wireless access point. So what sense does it make to have a channel adapter and then testing the plug, which you have been terminating in the field, and you will not test it because the channel adapter is not testing it as per definition of the standards. That's why you need a patch cord adapter. Patch cord adapter, it looks the same. It looks, I have here my one with me. It looks, you see it on the picture, but it looks exactly this. It looks almost the same. So I'm putting it here in front of the camera. So they look similar. They have a socket, but the socket of the patch cord adapter is more sophisticated or more from a higher quality, because you want to measure that connector also. You want to have the influence, because this is one of the main things that you changed. You can have a quality cable that you bought, but the things you change is connecting it here in your socket and here on the plug that goes into your camera. So you want to measure that workmanship that you have done in the field, and you can only do that by using a patch cord adapter. So the long answer is then MPTL. For MPTL testing, you need on one side a permanent link adapter, on the other side patch cord adapter. For those who are interested, because it will take some time, I will show you, if you want to do the test of the MPTL and you will see it will not pass, or it will tell you, hey, you have the wrong adapter in place. You need to use a patch code adapter.
Yeah.
But I want to hold up the others with the questions. So.
Yeah. We have another question. Why does a system integrator need to purchase individual instruments to carry measurement on the same cable? So may I answer this, Werner?
Yeah.
Yeah, so we have different categories of the testers. We have certification testers, we have qualification testers, we have verification testers, which varies in its capabilities and it varies also in its price. Yeah, so it depends on what you are looking for. What do you need to measure? If you need to certify your cables, then you need to go with a certification testers. If you need just to qualify your qualify your cables, then you need to use the qualification testers, which will qualify the speed that you can get out of these cables. If you need to verify the wire map, you need to test the PoE, then we are using a verification tester. So you don't need to buy the three, but it really depends on what you are really looking for to work in the field.
Another question I have, which I answered already quickly in the panel. Why don't we integrate microscanner PoE into the Versiv DSX modules?
Yeah, if you answered already, so I mean, the first answer would be, we want to focus with the Versiv on certification, physical layer testing. The PoE testing, it's another type of test. It's not really layer 2, maybe it is layer. It's on a higher level, and it's not really an active test, but you measure that power, and it's not a certification test to measure that power that comes from a device. That's one. Again, and the certification is mainly to get that certification, that report that you need for the warranty of the cable. The PoE test is more troubleshooting. You need it in case that camera is not working because you think that the power that comes is not the right power. So you want to physically measure that power that comes. That's why we keep it separate. Sal also just mentioned we have verification tools, we have qualification tools, and we have certification tools. Yeah, it would be great, of course, if you put them all together in one device. That's maybe something we should go back to R&D. But then if you just need a simple verification tool, yeah, then you have to pay what, more than $10,000 just to verify the wire map and the length of the cable. It would be nice if you all buy that, but I don't think everyone can then afford it. And that's maybe a long answer. If you have more.
Yeah, I think you mentioned it. I would call it also for two ways: certification or operational. You are in operational team, you might need the MSPoE. If you are in installation and certification, you need the SX. The next question, which is a great one, why do we need to have patch code adapter for every single category? So, is there any universal patch code adapter like the channel adapter that we have?
Again, because we do measure this connector, so because each standard Cat 6, Cat 6A, they have their own parameters for their own limits and their own parameters to test it. On the other side, you have what we call the center plug parameters again. So for each standard, they could be different, and that's why for each standard we need to have a different socket that is adapted for these specific parameters for that standard to measure it. That's why you have for each standard you will have a different patch cord adapter, because these sockets will be different for each standard. Anything else?
I would ask one more question and leave the remaining to Salah as well. Will there be a PoE on Cable IQ?
Will there be a PoE on Cable IQ?
I think the PoE plus the PoE plus measurement that you were talking about in the functionalities of the microscanner PoE.
I think Cable IQ is already, it's very nice equipment for qualification of the cable. I think it would be nice to have PoE tests also on it, but I think we should then think on developing something new, cable IQ type of equipment, and watch out what will come. I don't know if someone else will we have. Yeah. I think we'll keep watching Fluke Network introductions, I would say.
Yeah, and then we have a commercial question that I think we will answer later on. So someone is asking about the microtest micro scanner, the price, yeah, the rough price. I think we should answer it later on. So yeah, you can contact us later on and we will help you with this. Does the MPTL test result show the list of compliant PoE standards?
MPTL.
In the microscanner PoE, I think. Yeah.
No, it's a Cat6, Cat6a MPTL test. It will still tell you which speeds will go over that cable. And then the PoE standards, it's giving you the applications that will run over that standard that you tested. So it will still be 1 gig, 10 gig, whatever is applicable over that cable.
And the question, can you buy the patch cord adapter separately? We have a DSX 5000.
Yes, of course, you can buy that separately.
Yeah.
Of course, it's even the way we sell it at the moment, because if you would add all adapters for all the categories in the package, then the price would become a little high. And you saw in the beginning, there are also people that don't install CCTV, that was now CCTV cameras. So there are still people doing the standard permanent link test and the standard installations of wall outlet till patch panel. So they don't need it. So why they should then pay for it and buy it in the package, and they don't need it? Because again, and I may be repeating, this socket is very specific. It's a high quality, so that it's not cheap. Channel, if you would compare channel adapter, would be cheaper. So that's why, yeah, you have to select which standards you are going to use for MPTL. Is it Cat5e, Cat6, Cat6a? That we make then that you can select it separately. Our partners mostly, they make then a bundle. They say, okay, you need a solution for Cat6a CCTV cameras. This is the solution, which will then be a DSX 5000 or 8000 with a specific patch code.
Yeah, there is a question. Yeah, there is a question. Loop resistance required for all network?
Yeah, so I think I touched that also. It's not a requirement as per the standards, but we recommend to test it. Some consultants will recommend to test it. And even if no one recommends or no one tells you to test it, it's a recommendation. You should test it, especially if it is for PoE installations, because it will give you a better indication of the quality of the cable. If you don't test it, and later things happen, and we have experience, we have projects that have been done in the field. So, I mean, I can tell that story. So someone says, okay, I have a project, I take the project on because I took some cheaper cable to reduce the price of the product, the project. So they install the project, everything passes, the Cat6 or Cat6a, what I did. Yeah? And then they started adding the cameras because there was CCTV security cameras required. And then first camera, second, 50 cameras that were all fine till camera number 100 was switched on. Suddenly everything collapses. And then later they found out, hey, the resistance unbalance was not within the limits. And this was causing that the PoE delivery to these cameras was not working properly. The whole system was not working. So the system integrator who took the project and tried to save on the cost of the cable, he was, I call it screwed, because it had to be done all again with other higher quality cable. So we recommend test it, please, especially if you have PoE devices being connected there.
Yeah, And there is a confusion, a question. Higher category patch code adapters are backward compatible to lower categories?
No, so it's always same answer. Each patch code adapter has their unique parameters for that specific standard. So Cat6a patch code adapter, you cannot use it for Cat6 or Cat5e because they have other parameters. It's another connector that we need in that patch code adapter. No, they are not backwards or downwards compatible. You need to have for each specific standard the corresponding patch code adapter.
Yeah, which cable should be used for PoE transmission? Cat5, Cat6, Cat7?
Remember the first slides I showed you? The data is, you define the data transmission, Cat6, Cat6a, Cat5e, yeah, that's for data. If you are going to transmit PoE, it will heat up the cable. To avoid or to have it less heating up, you could increase the category. That's one recommendation. There are other recommendations. That's another presentation I think we can do. You could, for example, instead of having one bundle with, let's say, 50 cables, let's say, you make 3 smaller bundles. So the heating is dissipated or is spread over the smaller bundles. That's another way to avoid this heating up. But one of the solutions is to say, I'm going to test or install Cat6a cable and having an installation Cat6a, although it's only required to have Cat6, just to make sure that the heating up that will be generated by the PoE devices will not affect too much my installation. Not sure if it answered the question, but there is no Cat6 PoE, for example. It does not.
Yeah, there is a question. What about the ISO standard? As we noted, only TIA standard.
ISO, they have similar definitions. You saw that for MPTL, I think. It was here. It's also TIA. ISO, they have Pixie adopted it. ISO, indeed, they do not have yet agreement on MPTL. So it's only TIA at the moment. They have a clear definition of MPTL. ISO does not have it yet. That's correct.
Yeah. And can you use the patch code adapter to generate the other parameters for that specific cable for Cat6? So if we use the patch code adapter, can we test all the parameters for the Cat6 cable if we use the Cat6 patch code adapter?
So I don't get the
Can you use the patch code adapter to generate other parameters for that specific cable? So, for example, if we have a patch code code for Cat6, we can test parameters. Yeah.
Yes. So if you want to certify a patch code of Cat6, for example, then you need 2 patch code adapters on main and remote unit, and you can certify that patch code adapter with all the parameters as per the standards, which are same as permanent link or channel, next, LFX, etc. for patch code. I'm not sure if I'm answering. You can.
I think we can add another topic. We can add to it if maybe the person who asked this question, if they can use the patch code adapter instead of a channel adapter if they want to do a channel test. I think this is not a proper test then you go into a wrong practice. The versive will tell you a warning that you're using a wrong adapter when you're doing a test. So if you have an alarm from the test that you're using a wrong test, don't force the test to continue, because even if the tester will override your warning and then say, yes, I will start testing, you might be surprised by the customer or the vendor or the consultant coming and telling you that this methodology of test is not acceptable and I'm rejecting the test. Then you need to repeat the test again. So make use of each adapter in its own particular way it's meant to be.
There are more questions? Otherwise, I'm happy to show you how it shows in the tester for those who still want to hang on.
I think we have two nice questions. We have, we sell usually the patch code adapter in pair, or are we selling them individually now in one piece by one piece?
So as you wish, you can buy just one patch cord adapter because you only need one. So yes, we sell it in single units or in a set of 2 units. Because if you have a set of 2, you can then also use it for patch cord testing. We didn't touch this here, but if you, I saw in the beginning in the polling, so a lot of people are still doing channel testing for cameras. The question is why channel? In principle, you don't need to do channel. If you have a permanent link test and you test the patch cords, you certify them, then your channel will work. So why still to test a channel test? So if you buy a set of patch cord adapters, you can also do then the patch cord certification to make sure the channel will work. But we sell also single units for MPTL specifically.
And the next question, do we have any length limitation? What is the minimum length for the MPTL testing? I think
a minimum length.
I think it goes back to the TIA limitation of what's the minimum length of a cable. It's not in us, it's a limitation in the.
I'm aware of. The maximum length is 90 meters, but minimum length, I'm not aware. Unless if you know it or Salah knows it.
I think we can answer that, pull out this information and get back to the person who asked this question through our tech support.
Yeah, I think we finished the question. There is one question about the commercial. The commercial can be discussed to separate, not in the webinar. Yeah, so I think the questions are finished. So if you have time to show,
those I have time. Those who are online, if they have time. So if you want to log off, fine. So what I'm doing here, I have a test setup with a tester and some cables, but instead of showing the screen, or you will be able to see it also here. You can also see it here on, you should see it on the screen also, yeah? Well, Salah, can you confirm? You also see the screen on the Linkware PC, huh?
Yes, yes.
Yes.
Okay, so you can follow. But first I will do a standard permanent link test. So I have a cable, which I will use, a permanent link cable with 2 sockets on it. I will try to do a standard permanent link test. So I have my permanent link adapters. Connection. Connected. So on the tester, I have already standard set it up. So you have Cat6a permanent link. It's already set up as that. If you want to change it, you know, our equipment is pretty easy to change settings. If you want to change something, just select the other test. But at this moment, we don't have to change it. So we use the selected. It's the standard permanent link test. Yeah, I'm the operator, and it's our PoE webinar project now. So let's do a test and see if that works. Pass or fail, doesn't matter now, just to show you. This is a permanent link test. So I have on both sides, I have the permanent link adapter, maybe not clear on the camera, but we always have the remote unit with the permanent link adapter on it. Yeah? So you see it's a pass. You can measure performance. It's a standard PoE, standard permanent link test. So you will see the length, resistance loss, next, power from next, etc., as required by permanent link standard. So you do not see now, remember the resistance unbalance that we talked about, nor other tests yet, because we have selected the standard permanent link test. So now imagine we want to do an MPTL test. So for that, I have now one cable. On one side, there is the plug that goes into the camera, and imagine the other is a socket that is on your patch panel. Just very simple. It's not Cat6a. You will see it will give maybe a failure, but just to show you how the setup happens. So instead of using the permanent link adapter, I'm going to use, first I will do, let's see what will happen. I will use a channel adapter, as we discussed. So, and then I will connect one side my permanent link adapter, and on the other side I will connect my connector straight into, in this case, the channel adapter, just to see what will happen as set up. So we go to the home screen, and instead of permanent link, we want now to do an MPTL test. Already predefined it. Nevertheless, I can show you if you want to change it in your settings. You can go into your settings and select the MPTL. They are now in my last used settings. If they are not there, you have to click on the more and then go into your TIA settings. There you see, for example, Cat6a. And in Cat6a, you will find the standard permanent link. There is the plus all, plus PoE, channel test, and here you see MPTL. Maybe already a few words here. What are all these differences? Permanent link channel, I think you know that. This is with channel adapters, including your patch cords that you will use with the equipment. Standard is permanent link. That's a test we just did. Now you have here tests like plus all, plus PoE, and you have the MPTL. So we will first do the MPTL, but you could also do it plus PoE. Now, what is the plus PoE test? That's what we explained during the webinar. That is the resistance unbalance testing. There are a few other tests. We did not discuss this during this webinar. There is something about the shielding, for example. So there are a few more tests that you can do. That's why there is also an indication plus all. That are even some other additional tests which can be done. So now we will do the MPTL. Let's do it step by step. Later we can maybe try plus PoE. What will be the difference? So let's select the Cat6a MPTL. Why Cat6a? Because you will see my patch cord adapter. I only have the Cat6a now at the moment. So we'll do the Cat6a MPTL. Let's save it. Now they are now all MPTL, but that's fine. So I can use this one now. Use selected. So it is now Cat6a MPTL. I did connect the channel, so let's see what happens if I start the test. Well, the first message I get now, hey, error, the adapter on the remote tester is not compatible with the current reference or the selected limit. Try another adapter. So the equipment is recognizing the adapter. That, hey, you are trying to do an MPTL test, but you are not using the right adapter. This is something it's already nice to have because it helps you, it guides you to do the test in the right way from the first time. Consider that or reconsider if you are using or trying or are interested for other brands. There is no one else who will do this. You can select maybe MPTL or some test, and if you use the right or the wrong adapter, they will go straight through it and they will not give you any error or warning. So I have to change that adapter, and I will use the right Cat6a patch cord adapter. So change that adapter. So good to hear always these beeps that I am connected, so I don't need to come back always to my screen and check, hey, am I connected now? No, the beeps are telling me that I am connected. So I start the test again. I have to tell you, yeah, it's a Cat6 cable, so there is a chance it gives a fail or a pass star. Or Cat6 connector. So yeah, it's a pass star. It's just within the limits. But just wanted to show you for the setup, hey, for MPTL, you need one permanent link adapter and one patch cord adapter. If you don't have it, it will give you an error that you have the wrong parameter. Now for the rest, it's all the same. You have still your resistance, insertion loss, all the parameters are still the same as a permanent link test, but you had to use the right connector, the patch cord adapter. You know? Now you don't see the resistance unbalance here. Why not? Because I did not select it. Remember, it's not a must to test the resistance unbalance, but we recommend to do that. So, by the way, you can go into diagnostics and you can do some crosstalk analyzer to show, hey, where is the problem? In this case, here on one side, there is a bad connector. I can show you it's my demo setup, so you can see disconnected. So this is I did a Cat6 test, but this is a Cat6 connector. So you saw it's a pass-fail, so that means there is something not good on your installation. So let's go back now to the home screen and let's ask now for the resistance unbalance, which is related to PoE. So in the selection, you want to edit it and do let's do permanent link with PoE. So there's MPTL plus PoE. Okay, let's do the MPTL PoE because I still have the setup for MPTL plus PoE. Save it. I use the selected now and I do my test. It clearly shows now it's MPTL plus PoE. Again, it will be fail or pass star because I have one Cat6 connector. Doesn't matter. Just want to show you. You see, automatically generates also diagnostics. Again, because it's a fail, there will be diagnostics. But now in the performance, so you see here there is the resistance measurement. And you see also because it is not a must. It is what we call this blue indicator here that says it's the information. It's not really required for your test, but we do test it now. And you see here the loop resistance, the pair unbalance, and the pair-to-pair unbalance. So pair unbalance here is the values that we measure and the limits that should be there. And then you have the pair-to-pair unbalance. I should go back to my permanent link and do the setup. Bottom line, just to show you how easy it is to find in the menu for your test setup. Yeah. If you go in the home, say instead of Cat6 MPTL, you select it, Cat6 plus PoE, only TIA Cat6A plus PoE. Save it. Use the selected. Maybe going fast. Test. It's now with the better connector. Now you see the resistance with the pair unbalance with the limits that are there, the 0.2 that is required, and the pair-to-pair unbalance with the limits, and it gives you a pass against these limits. So this type of tests, not everyone is doing that or can do that because you can, maybe not clear on the presentation, but you see this limit, it's 0.2 ohm. It's not 0 ohm, and the value that you measure is 0.014 ohm. It's very, very, very small, but it's not a short circuit. So we are measuring this resistance unbalance. We show the value, and it is at a certain accuracy because it has to be in the 0.2 ohm. So it's pretty high technology, I would say, to do this. By the way, this is one of the reasons why we could not do that with our previous equipment. Some people, they say, I still have DTX, can you upgrade, blah, blah, blah. So no, this type of measurements cannot be done with our old DTX because this needed a complete new redesign of the electronics on that equipment. Yeah, just want to show you that, hey, it's easy to find in the settings. Select your right limits with MPTL, with PoE or without PoE, and do then the test accordingly. If your adapter is not the right one, it will give you a warning, but all the rest is still there. So all your other results, your next with all the graphs are still there. Any other questions, or otherwise we will. Were there other questions that came in the meantime? No?
Yeah, we have one question that came in the normal chat. Again, coming back to the same process. The question came from Badr, and the question: what is the best way to test PoE cam link? So again, going back to the MPTL, if we're gonna use RJ45 jack on one side and RJ45 male on the other side, it's MPTL measurement. And to know more about MPTL, you can always go back to our Fluke Networks website. Knowledge base. There's a lot of documentation around MPTL. Just search on MPTL, you'll find it there. If you still have some challenges with that, feel free to reach to any of three of us. We'll be more than happy to help you and direct you to the identification of the right methodology of MPTL. I think we're good with that. No more questions from my side.
Thank you very much.
Okay, then thank you very much for coming on board. Watching out for the next invite you will get. When is it and what is it, Salah? You are doing it Monday?
Yeah, it will be on Monday. It will be on Monday. We will talk about how to read the copper cable certification report. Yeah.
Okay. So see you again on Monday, and always nice to stay in touch and yeah, stay at home, but still stay in touch. And it's a good moment to learn about latest technologies and refresh ourselves about all the latest and prepare for it. So if you did not have this MSPoE or the patch cord adapter, maybe it's time to put it in your wish list and make some corrections, and that you have the right things once we are coming out of this unfortunate situation out there. Thanks. Stay safe. See you next week.